Hello viewers, I am Kausalya. Today we are going to solve problem number 2 in time response analysis chapter. And the problem is a positional control system with velocity feedback is shown in figure. What is the response of the system for unit step input? So this is our given block diagram. So our first step is we have to find the closed loop transfer function. So as we all know, the closed loop transfer function, the general expression is C of s by R of s is equal to G of s divided by 1 plus G of s into H of s. So here from this diagram, this is our G of s, that is feed forward element, and this is our H of s, this is our feedback element, right? Now we are going to substitute the values of G of s and H of s respectively here in this formula. So again this is our G of s, right? So G of s divided by 1 plus again G of s, and here the H of s is 0.1 s plus 1. So here in the place of H of s we have substituted 0.1 s plus 1. And the next step is taking LCM. So when you take LCM here, as we all know, you have to multiply 1 into s plus 2. So here s into s plus 2 plus 100 into this 0.1 s plus 1 remains as such, and the entire term divided by s into s plus 2. So here as both the denominator terms are same, they cancel each other, and finally we are having an expression like this, that is 100 by s into s plus 2 plus 100 into 0.1 becomes 10 here, so 10s plus 1 into 100 becomes 100, right? And the reduced form is here I am having 2s plus 10s. So when you add these two elements, we are having s square plus 12s plus 100, right? Because here this 2s and this 10s are added. And finally C of s by R of s, we are having an expression like this. So now the type of input is unit step input, right? It is given in the problem. So now as we all know, C of s is your output and R of s is the input. So for unit step input, the value of R of s is nothing but 1 by s. So here from this expression, I am moving this R of s to the right hand side. So C of s is equal to R of s into this expression, and the value of R of s is 1 by s for a unit step input. So in the place of R of s, I have substituted 1 by s here, right? And the next step is, so this is our given expression, right? This is the expression we had find out finally. And now we are going to solve this expression. So by partial fraction expansion, so here this equation can be written as, that is 100 by s into s square plus 12s plus 100 can be written like this. So here when you look carefully, you see this is a quadratic equation, right? And this quadratic equation will have roots, like that is what to say, complex roots, okay? So here as they have, as while solving this root we are getting complex roots, we cannot split this equation into two independent forms. So here we are writing that term as bs plus c, because when you solve this quadratic equation you are getting quadratic, that is not proper roots, you are having complex roots, complex conjugate roots. So here when you have quadratic equation like this, we have to write expression as bs plus c, right? And the next thing is, again we are taking the LCM here. So here we are having s, so this a gets multiplied with this equation, s square plus 12s plus 100 plus again this bs plus c gets multiplied with this s here, right? So again here both the denominator terms are same, so they cancel each other, and finally we are having the remaining terms like this, that is 100 equal to a into s square plus 12s plus 100 plus s into bs plus c, right? Now I am going to multiply here. So a into s square, a square, and a into 12s becomes 12as plus a into 100 becomes 100a. plus again s into bs becomes bs square plus again s into c becomes cs. Now we are going to find the values of a, b and c. So from this equation, just initially equate the value of constant. So in the left hand side you are having 100 and in the right hand side you are having 100a, because these are the constants, that is they don't have any s term. So when you equate, the value of a is easily found as 1, right? Here the next step is we are going to equate the coefficient of s. So coefficient of s is, here there are no s terms, so the left hand side becomes 0, and when you consider the right hand side, you see we are having 12a and here I am having c. So 12a plus c is equal to 0. We had already find out the value of a here, so just substitute the value of a as 1 here. Finally, you will be having c is equal to minus 12. Right, now we had find out the values of a and c, and remaining term we have to find out the value of b. So for that, I am equating coefficient of s square here. So here in this case again, there is no s square term on the left hand side. When you take right hand side, you are having a s square and b s square. So when you equate the coefficients, you will be having a plus b. So here 0 is equal to a plus b, and we know the value of a. From that we are calculating the value of b as minus 1, right? Now we had find out the values of a, b and c. Now we are going to substitute these values in this expression number 1. This is our expression number 1. This is nothing but our c of s expression, right? And now I am going to substitute the values. So when you substitute the values, for a it is 1 and for b it is minus 1 and for c it is minus 12. Just here I have substituted the values, right? A plus bs plus c, the value of b is minus 1, so minus s, and c is minus 12, so minus 12 here, right? Since here both the terms have minus sign, I am taking this minus sign commonly outside. So when I take this minus sign outside, the remaining term will be s plus 12 by s square plus 12s plus 100, right? And the next thing is, again we are in need to solve this equation, because when you take inverse Laplace transform, the value of 1 by s for inverse Laplace transform is 1. But here you cannot directly apply inverse Laplace transform. So for that, I am rearranging, I am making some small changes here. So here I am splitting this 12 as 6 plus 6. That is s plus 12, I am writing it as s plus 6 because 6 plus 6 becomes 12 here, right? And the next thing is, I am splitting this 100 as 36 and 64. Why I am splitting it as 36 and 64? Why can't we are not splitting that one as 50 and 50? Because the reason is, here we are having 6, right? So here I am trying to bring 6 square, right? So only I had split this 100 as 36 and 64, right? Hope you people understand. And the next step is, here this is our last expression, right? And now again I am splitting this expression, that is 1 by s minus, I am splitting this s plus 6 as 2 terms, that is s plus 6 divided by s square plus 12s plus 36 plus 64, and again this 6 term alone, that is minus 6 here, because minus into plus becomes minus here. So minus 6 divided by s square plus 12s plus 36 plus 64, right? And here again I am simplifying, that is 1 by s as such minus s plus 6 divided by, here you just look at these three terms. These three terms can be written as s plus 6 the whole square, that is a plus b the whole square, because this is in the place of a and this is the place of b, right? So s square, here s square, so 6 square 36 I am having, and the formula is, that is a square plus b square plus 2ab, right? 2 in the place of a I am having s, and the place of b I am having 6. So I am having 12s, right? So I am reducing this expression as s plus 6 the whole square, right? Plus, and this 64 can be written as 8 square, right? And the next thing is again minus 6 divided by, again I am reducing this denominator term as s plus 6 the whole square plus 8 square. And the next step is, you see here, for taking inverse Laplace transformation, I am having formula, direct formula for this expression. But here I cannot solve this expression directly. So here I am including, that is I am multiplying and dividing this expression by 8. So here I am multiplying with 8 and here I am dividing by 8. Right. So this is our C of S expression. But what is the thing I need? I need C of t. So for bringing C of t, I have to take inverse Laplace transformation. So when I take inverse Laplace transformation, I am having expression. That is, for these expressions, I have to take inverse Laplace transform. So before that, let us see what are all the formulas. So inverse Laplace transformation of 1 by s is nothing but 1. And inverse Laplace transformation of s plus a by s plus a whole square plus b square is nothing but e power minus at into cos bt. These are all just formulas. I hope you people have studied these formulas during your school days. And the next, finally, and again this is also inverse Laplace transformation of a by s plus b the whole square plus a square is e power minus bt into cos at. Right. So here I am having the expressions accordingly. You see, s plus a, I am having s plus 6 divided by s plus a whole square, s plus 6 whole square plus some b square. Here in the place of b square I am having 8 square. So this equation can be written as e power minus at. So in the place of a I am having 6 here. So e power minus 60. And the place of b I am having 8. So I have to write it as cos 80. So e power minus 60 into cos 80, right? And the next thing is, here I am having minus 6 by 8. So just keep this minus 6 by 8 as such. So here for this expression I am having formula. And the formula is, you see, this is our formula. That is e power minus bt into cos 80. When I apply this formula over here for this expression gets reduced as e power minus 60 into sine 80, right? And finally here in the last two terms e power minus 60 is common. So when you take e power minus 60 outside, the remaining terms are, that is I am taking minus e power minus 60 outside. So minus e power minus 60, whenever it is taken out, the remaining terms are cos 80 plus 6 by 8 into sine 80. That is, this is our final answer. The question is, we are asked to find the final output response. So whenever response is asked, our final expression should contain only t terms, that is response in terms of time. So C of t is nothing but this is our final answer. Hope you people understand the problem. Thank you.